कैसे हो आप सभी लोग? आई होप सारे अच्छे होंगे। सो टुडे आई एम बैक विद अनदर इंपॉर्टेंट टॉपिक ऑन मैथमेटिक्स, दैट इज अ बाइनोमियल थ्योरम। नाउ ये वाला जो टॉपिक है वो क्लास 11 के स्टार्टिंग में पढ़ाया जाता है इन द टॉपिक ऑफ अलजेब्रा। सो ये काफ़ी ज़्यादा इंपॉर्टेंट टॉपिक है और काफ़ी अच्छा वेटेज रखता है इस पर्टिकुलर पोर्शन ऑफ टॉपिक से, ठीक है। अब अगर प्रीवियस ईयर क्वेश्चन उठा के देखोगे, जेई मेंस या जेई एडवांस को उठा के देखोगे तो काफ़ी ज़्यादा वेटेज अच्छा रहता है। सो आई विल बी स्टार्टिंग विद द बेसिक्स ऑफ द बाइनोमियल थ्योरम एंड वी विल बिल्डिंग ऑन द थ्योरी in the upcoming lectures and so this will be the first lecture of today's session, and my name is Sirsha and I'm a BTech student at IIT Kharagpur. Okay, so let us get started. So today's goal will be on focusing the binomial theorem and its basics, and then we move on to the starting about the topics of general theorem as well as solving some questions on it. Okay, so if you search about the topic of binomial theorem, now there will be lots of questions which involves general terms. Okay, so whenever we were given with any expansion of a expression, you have to basically focus your things on the general term situation, and there will be lots of questions involving in JEE mains which is based on general term. Okay, so that makes up this particular topic is very hot topic for JEE Mains as well as JEE Advanced Examination. Even you are someone who is preparing for a school level mathematics topic, this topic plays a crucial role in your preparation. All right. So let's get started with that only. Okay. So what do you mean by binomial theorem? Now, why do we need to study our binomial theorem? So before starting our binomial theorem, I would like to introduce you to an important concept of expression, which is known as binomial expression. So what do you mean by binomial expression? Okay. So as you have heard, this word expression is very common to all of you. Okay. So this expression definitely in algebra, you have seen any two independent terms as written as some kind of a expression. Okay. Involving some variables in x, y, or z, and any other alphabets. Okay. So binomial expression is basically an algebraic expression. Okay. So if you write the definition something like this, so it is like an algebraic expression which which involves two terms. Okay. Two independent terms. Okay. Now, what do you mean by independent terms? I will make it very clear in the examples. Okay, two independent terms with two independent terms with positive as well as negative sign in between them. Sign in between them. Okay. So this is something which is called the binomial expression. Now, why it is very necessary to study about binomial expression before starting the topic of binomial theorem? Because the entire chapter you're going to be focusing on binomial expression and their expansions. Okay, all right. So binomial expansions are defined in this way that any such algebraic expression which involves two independent terms, okay, involving some variables with positive or negative sign in between them. All right. So for example, let me take some example for binomial expressions. So if you think of some simple examples, like if I have a any expression something as x plus y, this is basically a binomial expression which involves two variable x and y. Similarly, another expression like ax plus by is also a binomial expression which involves two variables, and the coefficient of x variable is a and the coefficient of y variable is b. Okay, and some other examples include like p by x square minus q by x to the power 4. So this is also a binomial expression, okay, involving two different variables with different powers. Now you must be wondering that these variables are basically same variable, but they have different powers. So they can also be some independent terms. Hence, these particular two terms, basically they cannot be clubbed together. That means if we cannot be clubbing those two terms, then such particular expression is known as binomial expression. But in this particular scenario, if we take p by x square minus q by x to the power 4, we can club these terms as, if we take x to the power 4 as the denominator, and then we write this particular expression as px square minus q. So we can club it as a single term. So therefore, this particular example doesn't fall into the category of binomial expression. All right. So binomial expression definitely implies that there will be two basically independent terms which cannot be clubbed and form a single term. All right. So this particular example doesn't encounter in the binomial expression. All right. So if we talk about some other examples, like we have another term as 1 by x plus 4 by x y square. So we can club this particular two terms as a single term, but their two terms will involve two particular different variables. In that particular logic, we do not say that those basically two terms are basically independent terms, and hence they are basically expressed as binomial expression. All right. So the entire chapter we will be dealing with the binomial expression. Now at the end of the chapter, I will be also starting about topic of multinomial theorem. Okay, now multinomial theorem basically involves multinomial expressions. Now, what does we mean by multinomial expression? So at the end of the chapter, you will see that there will be some questions which will be taken up the topic of multinomial theorem. Now, multinomial theorem involves multinomial expression. That means such an expression which involves more than two variables. Such an expression which involves expression involving more than two terms. All right. So such an expression which involves more than two terms, such expressions are known as multinomial expression. All right. So the entire chapter will be basically focusing on binomial theorem. At the end of the chapter, we will be focusing on multinomial theorem. All right. So the first heading that we start with is binomial theorem. Okay. Now, before starting on the binomial theorem, I want to take some few important understanding of fundamentals of mathematics. That is basically factorial notation. So you must have known what is factorial. Okay. So if you are knowing what is factorial, and factorial for a particular number is always calculated for a whole number. All right. So what is a factorial? Factorial basically is mean by continued product. Factorial is referred as continued product of any number starting from 1 to continue to the given number. Okay. So if I say there is n factorial, so factorial notation is given as n exclamation mark, or you can also represent this factorial as this way. Okay. Both of the same represent the same thing, that is factorial. So this n factorial basically, where n is basically an whole number, all right, it is an whole number. So n factorial is defined in the fashion is as such that, so if it is a whole number, we have to basically write n factorial as 1 into 2 into 3 into and so on, continued up to n. So unless you go to the end of the number, that is n, you have to continuously go on taking the product. That means you have to do the continued product of all the terms in form 1 to n. Okay. So that basically refers to as a factorial notation. Now, in this particular topic of binomial theorem, we need some another important term that is basically known as a combinatorial coefficient. Okay, combinatorial coefficient. Okay, so what is a combinatorial coefficient? It is defined in the fashion that is NCR. So if you are someone who has basically covered the topic of permutation and combination, you have been very familiar with this particular notation. And this particular notation, that is NCR, basically referred to as selecting n objects. Okay, selecting r objects, r identical objects, selecting identical, okay, r identical objects out of total n objects. Okay, out of n objects. So if you are given with n objects, and if you are told to basically select any identical object, that means unique objects or entities out of those n elements or n objects, then we use the notation that is NCR. That definitely means combinatorial coefficient. So this particular combinatorial coefficient is defined in the fashion NCR is defined as n factorial divided by n minus r factorial into r factorial. Okay, so this is how you define the NCR. Okay, so this is basically the definition of NCR. Now, how does this particular NCR comes? I will basically take up the proof of this NCR in the chapter of PNC, that is permutation and combination. So for now, you basically have to be carrying forward with this particular idea, that is NCR is equal to n factorial divided by n minus r factorial into r factorial. So this basically, these two important fundamentals will be basically used in the expression or the binomial theorem. Okay, so the binomial theorem, the rule which binomial theorem states is that it is basically such a rule which basically gives the expansion terms of any particular binomial expression which is raised to the power of some positive indices, okay, or positive integer. For example, if we have to expand any term, for example, we take a simple term expansion, that is x plus y whole square. So what do you basically write for this expansion? We have already studied this particular expansion in your junior school level as x square plus 2x into y plus y square. All right. And similarly, I have also studied about this particular expression, that is x plus y ka whole cube as x cube plus 3x square y plus 3 times of xy square plus y cube. Now you must be wondering how this particular expression comes into play. Now this particular expansion jo aata hai, that is basically comes from that idea of binomial theorem. Now what does binomial theorem basically states that? Now binomial theorem states that, for example, you have an expansion, okay. Now we will be talking about binomial theorem for the first time. So we will basically keeping our focus when the power, that is the index of this particular binomial expansion, is a positive integer. For example, we have a binomial expansion x plus y, and it is raised to the power of a positive integer, that is n. So we have n as a positive integer. Okay, so let me define n as some positive integer. Now the rule by which the power of a binomial expansion can be expanded is basically known as binomial theorem. So the theorem states that Now this particular theorem basically talks about the how we basically expand any binomial expansion which is raised to any positive integer coefficient, okay, positive integer number. All right, so this is basically the expansion as we write this expansion as, now this particular expansion comes as, that is nc0 x ki power n y ki power 0 plus nc1 x ki power n minus 1 y ki power 1 plus nc2 x ki power n minus 2 y ki power 2 and so on up to ncr x minus n minus r into y ki power r plus and continued up to, unless and until you get n, you continue, that is ncn x ki power 0 and y ki power n. So this is how we basically expand any binomial expansion. All right, so why this particular binomial expansion comes from, so you have to basically understand. Now let me try and see whether this particular binomial expansion fit into this particular definition. All right, so if we take up this particular definition of x plus y ki power whole square, that is basically, if we try to expand, it will be basically 2c0 x square and y ki power 0 plus 2c1 x ki power 1 y ki power 1 plus 2c2 x ki power 0 and y ki power 2. So this is how you expand, and 2c0 is basically equal to 1. Similarly, 2c2 is also equal to 1 and 2c1 is also equal to 2. All right, so you have to basically take care of another important thing. That is basically a short trick to remember how to calculate any commutatorial coefficient for any number. For example, you have to calculate combinatorial coefficient for NCR. So you can also calculate by doing this factorial method. But there is another easy method to solve this particular factorial. Okay, that is basically, it comes out by cancelling these product terms. Okay, that comes out by cancelling these product terms. So you have to do basically, for example, you have a commutatorial coefficient, for example 4c2. So how you calculate this 4c2 is basically you multiply 4 into 3 divided by 2. How this particular things comes into play. Now you have to remember this particular short trick in your mind as, that is basically you write 4 over here. Okay, whatever number is present over in the upper portion of C, you write this particular number over here and then multiply it with a lower number, that is a number which is less than 4, that is 3, and then divide by the number which is present over here. That's how you do it. That's a very simple and a very basic step. That's it. You basically have to expand for this NCR, then you can do it as n into n minus 1 and continue up to n minus 1 plus r, n minus r plus 1 and whole divided by r. So this is how we basically expand any terms for NCR. Now this particular definition comes from this particular factorial expansion only. So if you write this factorial n as n into n minus 1 into continue up to n minus r plus 1 into n minus r. So n minus r factorial and n minus r factorial get cancelled, because we know a very simple relation, that is n factorial can be written as n into n minus 1 factorial. Okay, so this is a very simple relation that we can write, because we know that basically n factorial starts from 1 into 2 into 3 into goes up to n. So this particular product can also be written as n into n minus 1 and multiplied up to 1. Okay, unless and until we reach 1. That means we can also write this as n into, and these particular terms again will be basically n minus 1 factorial, and hence this will be n into n minus 1 factorial. I hope this particular relation is clear. All right, so from here, this is basically a short trick that you must remember in order to calculate the commutatorial coefficient. All right, so with this we can write this expansion as x square plus this is 2 times of x into y plus this is y square. So I hope this particular definition fits into this, perfectly fits into this formula. All right, so now this particular definition plays very good when the index is basically an integer number. Now we will be basically in the upcoming lectures we will see how we basically expand for a binomial expansion which doesn't contain any integral indices. Okay, I hope that particular decision will be clear when I will be taking up that particular lecture. But since we are starting with the topic, you basically I have to get the idea of this particular expression. Now this particular expression can be basically expressed in terms of more general way, can be expressed as n x plus y ki power x plus y ki whole ki power n can also be written as in form of sigma, that is a general term. We can use the general notation and write it as r is equal to 0 up to n, and we can write this at NCR, that is basically NCR into x ki power n minus r into y ki power r. Now how this particular thing comes into play? Now I will be taking a few minutes. If you are someone who basically covered the topic of permutation and combination, then you basically will have a good understanding. In case you don't have any good understanding, you basically have to remember this particular relation, that is NCR basically means selecting r identical objects out of n objects. Okay, out of n objects. That means, so what does basically x plus y ki power n basically means, that you have to basically, for example, for any general term, you basically out of this, because we have already get an intuition or idea from this particular expansion terms, that is basically when you see that x plus y की power whole square जब calculate कर रहे थे तो जब power 2 था, 3 टर्म्स निकल रहे थे, और जब पावर 3 था तब 4 टर्म्स निकल रहे थे। सिमिलरली जब पावर 4 होगा तब 5 टर्म निकलेगा। दैट मीन्स दैट बेसिकली x प्लस वाई की पावर n में we will see that there it will have n plus 1 terms. It will have n plus 1 terms. Okay, so in the expansion of x plus y की power n, there will contain n plus 1 terms. All right. तो सिमिलर फैशन में अगर मैं पूछूं कि इस पर्टिकुलर एक्सपेंशन में भी n plus 1 टर्म्स मिलेगा, पर मैं अगर पूछता हूँ कि एक ऐसा टर्म होगा जिसमें x का पावर कुछ नहीं रहेगा, और एक ऐसा भी टर्म हो जिसमें y की पावर कुछ नहीं रहने वाला है, दैट इज द फर्स्ट टर्म, एंड सिमिलर द लास्ट टर्म विल हैव नथिंग इन द पावर ऑफ y x। ऑलराइट, सो सिमिलर अगर मैं पूछूं जिसमें कुछ पावर ऑफ x आने वाला है, सो सच टर्म्स आर बेसिकली n टर्म्स। ऑलराइट, जिसमें कुछ ना कुछ पावर ऑफ x आने वाला है या फिर कुछ ना कुछ पावर ऑफ y आने वाला है, तो उसका नंबर ऑफ टर्म्स बेसिकली देयर विल बी n नंबर ऑफ टर्म्स होने वाला है। ऑलराइट, सो अगर मेरे पास n नंबर ऑफ टर्म्स है और उनमें से मेरे को कोई जनरल टर्म उठाना है, फॉर एग्जांपल जनरल क्या लिख सकता हूँ, सो आई रिप्रेजेंट जनरल नंबर बेस r। ओके, सो मैं अगर ऐसे इंट्यूशन से बोलूं कि यू हैव टू बेसिकली सिलेक्ट r objects, r entities out of those n entities and raise this particular x to the power of n minus r. Okay, now why do we need this? For example, अगर आप इस पर्टिकुलर टर्म्स पे एक्सपेंशन में देखो तो बेसिकली इट विल कंटेन x की पावर n में टर्म कंटेंट करेगा, y की पावर n में टर्म कंटेंट करेगा, सिमिलरली x की पावर n माइनस 1, ऐसे करते करते बहुत सारे टर्म कंटेंट करने वाला है, जैसे n माइनस r, ऐसे टर्म्स भी रहने वाला है। तो इन पर्टिकुलर एक्सपेंशन से अगर मैं पूछूं कि व्हाट इज बेसिकली यहाँ से ऐसे कोई भी आठ पर्टिकुलर टर्म्स में लेना चाहता हूँ जहां पर x की पावर कुछ ना कुछ आने वाला है, सिमिलरली और जो रिमेनिंग टर्म्स हो जाने वाला है दैट इज बेसिकली आठ टर्म्स, और आर वाला एंटिटीज में सिलेक्ट करने वाला हूँ ऑफ विच विल कंटेन सम पावर ऑफ y, and that particular selection is basically done by NCR and in multiplied with x की power n minus r and multiplied with y की power r, and if you express this particular generalize the relation for all the whole terms, that is starting from r is equal to 0 to n, we basically get to the relation which is known as the binomial theorem, which is basically known as the binomial theorem, or the rule by which we basically expand any binomial expression. All right, so this particular thing is basically clear. All right, so you have to remember this particular definition by heart. Okay, you have to remember this particular expression by heart. Okay, I hope this particular relation is clear. All right, so in this particular expansion we see that there are basically terms involving nc0, nc1, nc2, ncr, so such terms are basically known as binomial coefficient, and these particular terms are known as binomial coefficient. अगर क्वेश्चन में काफी बार क्वेश्चन में होगा कि you have to basically calculate the sum of binomial coefficient rather than taking out only the sum of coefficient. All right, अगर कोफिशिएंट पूछे कि कोफिशिएंट ऑफ एनी पर्टिकुलर वेरिएबल, दैट विल बेसिकली विल बी वो पर्टिकुलर वेरिएबल के रेस्पेक्ट में कोफिशिएंट निकालना था, दैट इज बेसिकली बाइनोमियल कोफिशिएंट इन्वॉल्विंग द कोफिशिएंट, ओके, प्लस द और मल्टीप्लाइड विद द कोफिशिएंट टर्म्स। ऑलराइट, बट जब भी क्वेश्चन में अगर स्पेसिफिकली बोल दिया गया है कि यू हैव टू बेसिकली कैलकुलेट फॉर बाइनोमियल कोफिशिएंट, देन दे बेसिकली मींस दिस nc0, nc1, nc2 एंड ncr, वो वाला टर्म्स बेसिकली मीन करता है। आई होप दैट पर्टिकुलर रिलेशन वाज क्लियर। ऑलराइट, सो तो कुछ कुछ जनरल जो नोट है, जो बेसिकली जो इंपॉर्टेंट नोट है दैट आई विल बी टेकिंग अप, दैट बेसिकली द फर्स्ट इंपॉर्टेंट नोट you have to basically remember is that the number of terms in the expansion of in the expression, okay, this is basically expansion. Okay, I try to write expansion. In the expansion of, for example, I have a binomial expression such that ax plus by whole की power n, तो इसका expression में अगर पूछो what is the total number of terms in this particular expansion, then you will basically say that it will have n plus 1 terms. That is basically seen by induction. Okay, we have seen in this particular relation method. Okay, so similarly whenever we express any binomial expression which is in form of ax plus y की power n, we see that basically the expression contains decreasing power of x and increasing power of y. Okay, and this nc0, nc1 and nc2 are basically known as the binomial coefficient, which are basically coefficient as which are equidistant from the center. That means we also have seen a very important relation which is basically in PNC, and if you are someone who has not got PNC, then you might be seeing that particular thing, that is basically NCR is also equal to NC n minus r. That is basically it says that the number of terms, that is a binomial coefficient, are basically equidistant from both the sides, are equal from the beginning as well as from the end. That means if you see for the expansion of this particular quantity, that is if you see from this front end as well as on the back end, the first binomial coefficient is 1, and similarly this particular binomial coefficient also is 1 over here. Okay, so 1 over here and 1 over here. Similarly, you move forward, you will have 3 over here, and similarly from backside you will also find a 3 over here. That means NCR is also equal to NCR n minus r. All right, so this particular relation also plays a very important role. That is NCR is equal to NC n minus r. इस रिलेशन में भी काफी सारा क्वेश्चन आप क्वेश्चन देखोगे, ठीक है। ऑल राइट, So इसके साथ let me move forward and take up some important relations, that is basically relation involving कि मान लो आपके पास बाइनोमियल कोफिशिएंट एक्सप्रेशन मिल गया, दैट इज बेसिकली इन्वॉल्विंग अ नेगेटिव साइन, दैट इज x minus y की पावर n. Okay, so x minus y की power n, that basically involves a negative sign in place of a positive sign that is replaced with the coefficient. Okay, that is basically taken as or encountered as x plus minus y and इसका whole की power n. So how do we basically expand for this? And we basically expand this as nc0 x की power n minus y की power 0 plus nc1 x की power n minus 1 minus y की power 1, and this is how we basically expand for this particular binomial expression. All right, so we basically see that we have to remember only one formula which involves, that is a binomial expression which involves a positive sign, and other than all the cases we will basically incorporate it as a coefficient of that particular variable. All right, so this is basically a simple thing that you basically need to remember. All right, so there comes another very important relation. ना काफी बार क्वेश्चन में सॉल्व करने देखोगे कि बेसिकली एक क्वेश्चन सबसे ज्यादा इंपॉर्टेंट एक क्वेश्चन बनता है, दैट इज बेसिकली द सम ऑफ ऑल द बाइनोमियल कोफिशिएंट, दैट इज nc0 प्लस nc1 प्लस nc2 एंड सो ऑन अप टू ncn. ना ऐसा टाइप का क्वेश्चन में आपको क्या करना है, दैट इज बेसिकली द सम ऑफ बाइनोमियल कोफिशिएंट. ना ये वाला क्वेश्चन आप बाकी इन द आगे वाले चैप्टर्स में देखने वाले हो, और काफी सारा क्वेश्चन इसी पूरे चैप्टर में सॉल्व करने वाला है, बेसिकली द सम ऑफ द बाइनोमियल कोफिशिएंट. तो उसको सॉल्व करने का जो कैसे तरीका होता है, आई विल टेक अप इन द फर्दर लेक्चर्स. बट सिंस ये रिलेशन काफी इंपॉर्टेंट था, क्योंकि ये वाला रिलेशन आप सेट थ्योरी में भी यूज करने वाले हो एंड प्रोबेबिलिटी भी में भी यूज करने वाले हो, सो आई वांटेड टू टेक दिस पर्टिकुलर थ्योरम एज अ नोट. ओके, this particular formula as a note. Okay, that is basically sum of nc0 plus 2 n to nc1 plus nc2 and so on up to ncn. Now this particular relation is directly equal to n 2 की power n. Now how does this particular relation comes from? So if you think of an expression as that x plus y की power n, it can be written as nc0 x की power n and so on up to ncn up to y की power n. Now in place of x, if I replace with 1, and in place of y, if I replace with 1, then I get to the relation that is basically nc0. The right hand side becomes nc0 plus nc1 and so on up to ncn, and this particular relation is equal to 2 की power n. 2 की power n. So this is very important formula that you must remember in mind, that you must take care once you are solving questions of JEE Mains and JEE Advanced. All right. So this comes very handy. All right. So let us move forward and start some other important note. Okay. Now what is basically this chapter involves? Now basically this overview of the chapter is basically we'll be talking about mostly about basically the questions involving general term. अगर आपके पास जनरल टर्म का आइडिया हो जाए, जनरल टर्म कैसे निकालते हैं, एंड देन विल बेसिकली able to tackle the question which basically comes in different formats. All right, so जनरल टर्म का क्वेश्चन को सॉल्व करने से पहले आई वांट टू टेक अप एक छोटा सा इम्पोर्टेंट नोट था, दैट इज बेसिकली इफ वी हैव सम एक्सपेंशन दैट इज x प्लस y की पावर n minus x minus y की पावर n x minus y की पावर n, and in this particular relation we can definitely solve this binomial relation. But क्वेश्चन में डायरेक्टली पूछा था कि इसके रिलेशन में कितना नंबर ऑफ टर्म्स एक्सप्रेशन आने वाला है. ओके, आई मीन टू से द टर्म्स आने वाले हैं, व्हाट इज द टोटल नंबर ऑफ टर्म्स इन्वॉल्विंग दिस पर्टिकुलर बाइनोमियल एक्सपेंशन. तो इसको डायरेक्ट आप रिमेंबर कर सकते हो कि इफ n is odd, the total number of terms will become, total terms will come as n plus 1 by 2. Okay, you can check this by doing the expansion and cancelling the negative terms with the positive ones, and definitely will get something that the total number of terms will become n plus 1 by 2. And similarly, if n is even, if n becomes even number, okay, if n becomes even number, then you basically have terms as n by 2 plus 1. इतना terms निकालने वाला है. Okay, in this particular expansion of this binomial relation. All right. So let us move forward and let us start the most important topic of this particular chapter, that is basically the concept of general term. That is the concept of general term. All right. So what does the concept of general term has to say? ना आगे वाला जो चैप्टर में सारी चीजें देखने वाले हो वो बेसिकली इन्वॉल्व जनरल टर्म्स इन्वॉल्व होने वाला है. ठीक है, चाहे आप रिमाइंडर वाला क्वेश्चन सॉल्व करो, चाहे आप एक्सपेंशन वाला क्वेश्चन सॉल्व करो, चाहे आप कोफिशिएंट वाला क्वेश्चन सॉल्व करो, सारी चीज में रिमाइंडर जनरल टर्म का तो काफी ज्यादा इंपॉर्टेंस आने वाला है. सो जनरल टर्म बेसिकली इज बेसिकली द एक्सपेंशन का जो हम लोग लिखे थे, दैट इज x प्लस वाई की पावर n में जब जनरलाइज कर रहे थे रिलेशन, वी जनरलाइज इट एज r इज इक्वल टू 0 अप टू n, एंड वी रोट इट एज ncr. ओके, x की पावर n माइनस r and y की power r. Okay, so this particular quantity is basically known as a general term. this particular quantity is basically known as general term. Now, if I talk about now which particular this particular quantity represent which term, all right. So you will basically see that this particular quantity express the r plus 1th term, okay, the r plus 1th term. Now, how this particular relation comes is because the first term involves r is equal to 0. That means this particular quantity, that is NCR x ki power n minus r into y ki power r, is basically the r plus 1th term. Is the r plus 1th term. So, if you are given in a question that you basically have to calculate the t r plus 1th term, you will basically solve it by NCR x ki power n minus r into y ki power r. So, this is how you basically express for the general term. This is the way you basically express the general term. For example, if you have to write the general term for example, you have to write the term of sixth term. There is a sixth general term as the term number 6. Okay, that means you basically write it as r is t of 5 plus 1. That means the value of r is basically 5. So क्वेश्चन में काफी बार गलती ये हो जाता है कि t6 देख के अगर सिक्स टर्म निकालने बोलता है तो हम डायरेक्टली r की जगह 6 बैठा देते हैं. तो दैट्स अ वेरी रॉन्ग स्टेप दैट यू बेसिकली टेक. Now it should be written as r is equal to 5. Okay, so this is basically t 5 plus 1. That means this particular term will become, for example, there is in the index of this particular expression is n, so you basically take this as nc5. Okay, and then the variable ki power n minus 5 and the other variable ki power 5. Okay, so this is how basically write the sixth term of the particular binomial expression, the sixth term of any particular binomial expression which involves, and then let me write the expression as x plus y ki power n. तो इस पर्टिकुलर एक्सप्रेशन में अगर आपको 6 टर्म लिखने वाला है तो आपको r का वैल्यू 5 लेना है. दैट मींस 1 लेस देन द नंबर ऑफ टर्म, द नंबर टर्म व्हिच इज आस्क्ड इन द क्वेश्चन. ठीक है. अब जनरल टर्म का जो क्वेश्चन हम करते हैं तब एक और एक क्वेश्चन आता है कि यू हैव टू कैलकुलेट द टर्म फ्रॉम द एंड. ना ये जो हम लोग क्वेश्चन कर रहे थे दैट इज बेसिकली कैलकुलेटिंग द r plus 1th term from the beginning, r plus 1th term from beginning. Okay, we are basically calculating the r plus 1th term from beginning. Okay, now this particular term was actually calculated as ncr x की power. Okay, so we have the relation as x की power n minus r and y की power r in the expansion of x plus y की power n. Okay, but काफी बार क्वेश्चन में ये होता है, कि you have to basically calculate the rth term, or I mean to say, okay, or I mean to say the r plus 1th term from the end. Okay, from the end. सो हाउ वी बेसिकली सॉल्व दिस पर्टिकुलर क्वेश्चन. ना काफी बार आप बुक वगैरह वगैरह पढ़ते होंगे और कोई भी कोचिंग मटेरियल से पढ़ते होंगे तो वो उसके लिए एक बड़ा सा फॉर्मूला देते होंगे. बट आई डोंट बिलीव इन दिस फॉर्मूला. आई बेसिकली बिलीव इन वेरी शॉर्ट ट्रिक. ना अगर आप देखते हो, अगर एक छोटा चीज ऑब्जर्व करते हो, फॉर एग्जाम्पल इफ आई राइट द एक्सपेंशन ऑफ एक्स प्लस वाई की होल स्क्वायर, देन आई राइट इट एज एक्स स्क्वायर प्लस 2 टाइम्स ऑफ एक्स इंटू वाई प्लस वाई स्क्वायर. ना मैं अगर पूछूं कि व्हाट इज द सेकंड टर्म, व्हाट इज द फर्स्ट टर्म, okay, what is the first term, or let me say, ask you what is the second term, you'll basically say this is the second term is 2xy. Now similarly if I ask what is the first term, that is x square. Okay, now in this particular question the first term of this particular binomial expansion is same as the third term from the end, that is third term from the end. ना इस particular logic में क्वेश्चन बुक में दे रखा होगा, बट इसको सॉल्व करने का एक और एक तरीका होता है. फॉर एग्जाम्पल इफ यू हैव टू कैलकुलेट द थर्ड टर्म फ्रॉम द एंड, then you basically do another important thing, that is basically instead of x plus y, write it as y plus x ki power 2. Okay, and then you expand for this particular binomial relation, it will expand it as y square plus 2 times of yx plus x square. Now if you have to calculate the third term from the end is similar to calculating the third, for example you have to calculate the third term from the end, then it is similar to calculating the third term from the beginning of the binomial expression which involves, which जब सिर्फ रिप्लेस कर देना है, like x के जगह y को इंटरचेंज कर दो and then calculate the third term from the end, from the beginning, sorry. Okay, from the beginning you calculate the third term, that is basically from the beginning if you calculate the third term you will end up getting that third term as x square, which is basically the third term from the end for the relation x plus y की power n. Okay, I hope this particular intuition is clear. Now on this particular intuition, जब भी क्वेश्चन में पूछा जाए कि you have to basically calculate the r plus 1th term from the end of any particular relation, you don't need to memorize any particular formula. Instead you will do, for example you have the binomial expansion as x plus y की power n. Now you have to calculate the r plus 1th term from the end. You basically need to do nothing but just a simple step, that is basically replace the x with y and then write the expression for this particular for this expression. And in this expression, if you can find the r plus 1th term. Now if you find the r plus 1th term, then this particular term is same as the r plus 1th term from the end of this particular binomial relation, of this particular binomial expansion. I hope this particular simple intuition is clear. और ये काफी इंपॉर्टेंट सा क्वेश्चन बन जाता है, क्योंकि काफी बार क्वेश्चन में आपको बिगिनिंग और एंड से निकाल के आपको इक्वेट करना होता है कोफिशिएंट को, ठीक है। सो काफी बार क्वेश्चन में ये होता है कि हमको पता नहीं होता कि एंड से कैसे टर्म कैलकुलेट करें। इन दैट पर्टिकुलर सिनेरियो वी बेसिकली ट्राई टू रिमेंबर दोस फार्मूला एंड वी एंड अप गेटिंग अ रॉन्ग रिजल्ट। तो इससे बढ़िया कि आप टर्म्स को इंटरचेंज कर दो एंड देन डेफिनेटली कैलकुलेट द r plus 1 term from the beginning. All right, so this is basically an important step that you basically need to keep in mind. All right, so let me start up a very important and simple question with this particular lecture. All right, so this particular question, it has to say that now using binomial theorem, you basically have to show basically a given relation as 6 to the power n minus 5n always leaves a remainder, that is 1 when divided by 25. So 25 can be written as 5 square. Okay, so we basically have to use binomial theorem. Now what do you have studied as till now is basically the expansion of binomial theorem and basically writing the general term of the binomial theorem. That means, so for doing this such question, we basically have to prove this question, that is this particular expression. Now this is not a binomial expression. We can see that the expression is given out as 6n. Now let me represent that number as capital N, and this number is 6 to the power n minus 5 small n. All right. So this particular number, and where n is basically an integer number, where n is a positive integer, where n is a positive integer. All right. So it is said in the question that this particular number when divided by 25 always leaves a remainder 1. Okay, so we have to prove that. So how do we do so? So what we can see that this is 6. All right. So we can write 6 as 1 plus 5 to the power n. Now you must be arguing with me that we can write 6 as 2 plus 4 to the power n. We can also write 6 as 3 plus 3 to the power n. Alright. We can also write 6 as 1 plus 1 plus 4 to the power n. Now why do we only need to write 1 plus 5 to the power n? Now since we are studying the topic of binomial theorem, and since the question also asks us to do so, that in this particular question we have to use binomial theorem. So if we have to binomial theorem, then we basically have to use the two different terms, two terms, and which we cannot club together. But since we are basically taking this particular number from this only single quantity. All right, so why do we are doing so? Because we have to somehow get to the quantity which is basically involves 5n. We have to get a quantity which involves 5n, and the best way to give a 5n is basically do the expansion of 1 plus 5 to the power n. All right, so this is how we basically encounter or tackle the situation of 5n. So if we are able to tackle the situation of 5n such that कोई भी फैशन चल लेगा कि 5n कट जाए दोनों साइड से, कि 5n कट जाए और बाकी वाला नंबर में 5 स्क्वायर टाइम्स ऑफ कुछ कोई एक रैंडम नंबर आ जाए. In that particular scenario, we will say that the rest of the number is divisible by 5 square, and only the number which is not divisible is the remainder, that is a 1. All right. So if we see the expansion of 1 plus 5 to the power n, we can write this expansion as nc0 1 to the power n plus nc1 5 to the power 1 plus nc2 5 square and so on up to ncn 5 to the power n. All right. So we can do this particular expansion in this particular fashion. All right. So we can also write this expansion as, since we know that nc0 is basically 1, and that means this will give me 1 over here because 1 to the power n is 1 over here, and plus, and this particular quantity will yield me the number that is 5n. All right, 5n, and the remaining number will involve some number which is basically 5 square. If we take 5 square, then all the numbers are basically integer number. Then we can write this 5 square times of some integer quantity, and let the integer quantity be some capital X. All right, so we can this club this whole terms as 5 square times of X. That is an integral quantity over here. That means the expansion of 1 plus 5 to the power n can be written as 1 plus 5n plus 5 square times of some integral quantity. Now if we try to see, and if we try, this is basically 6 to the power n, and let me subtract 5n from here, then we get the number as 1 plus 5 square times of some positive integer, that is x. All right, now if we divide this whole number by 25, we see that this if we divide this whole number by 25, we see that this particular quantity is divisible, but the only quantity which is not divisible, this particular quantity is 1. That means if we divide this whole number, this whole quantity by 25, we will always get a remainder, will always yield a remainder, will yield remainder as 1, in all the cases, in all cases. All right, in all cases. All right. So this is a very important concept that you must remember in mind. All right. So if you're someone who is basically preparing for the school level at class 11, then you basically have to encounter this types of proof given, proof that questions. All right, which involves basically the concept of remainder. Now this is very important question that I wanted to take up. So okay, I hope you will remember these types of question. Okay. And in the upcoming lectures, I will take up the concept of factors and divisibility concepts. Okay. तो डिविजिबिलिटी जो कॉन्सेप्ट होता है वो भी काफी इंपॉर्टेंट रोल प्ले करता है इन योर स्टडी ऑफ बाइनोमियल थ्योरम. ठीक है, बाइनोमियल थ्योरम में काफी ज्यादा रिमाइंडर टाइप का क्वेश्चन बनता है जिसमें आपको डिविजिबिलिटी प्रॉब्लम और रिमाइंडर वाला प्रॉब्लम को ये चीज आपको जानना चाहिए. या फिर साइक्लिसिटी वाला प्रॉब्लम, लाइक फॉर एग्जांपल इफ यू हैव अ number which is basically 3 की power some higher quantities, and what will be the power of a prime number from that particular quantity. Okay, so that is basically done and solved by the concept of binomial theorem only. Okay, we will see in the upcoming lectures. All right. So with this, let us move to the second important question that I want to take up, and this question is basically based on the study of general term. This question is based on the study of general term. All right. So this question says that we have to find such value of r for which the coefficient of r plus 1th term, the r plus 5th term, and the 2r minus 5th term of this expansion are basically equal. Alright, so we have to basically find for the or argue on the value of r. So let me write the expansion as the expansion is given out in the question as 1 plus x to the power 34. So if I try to expand this particular binomial expansion, we can write this as sigma r is equal to 0 up to 34 and NC, n की जगह मैं 34 बैठाऊंगा, n 34 CR into x की power 34 minus r into y की power r. Okay, so this is how basically get to the general term of any binomial expansion. All right. So if we think about the general term, now it is said that the coefficient of r plus 5th term, the coefficient of r plus 5th term, since we are talking about r minus 5th term, that is basically equal to r minus 6 plus of 1. That means the actual value of r which we use in this particular place of r is basically r minus 6. So we can write this particular r term, r minus 5th term as nc r minus 6. Okay, 1 की power n minus r plus 6 into x की power r minus 6. So you can also write this as 34 c r minus 6 into x की power r minus 6. Okay, but since we are in the question, we have to basically talk about only the coefficient equality. That means we don't need to worry about the x की power क्या आने वाला, that is basically r minus 6. We don't need to worry about x की power 6. And similar fashion, we'll write that term, the 2r minus 1th term as in place of n we will write 34 c. Now we can write this as 2r minus 2 and plus of 1. So we'll write in place of this particular r, we'll write it as 2r minus of 2 and 1 की power 34 minus 2r plus of 2 and 1 की power कुछ भी हो तो 1 ही आने वाला है, and similarly into x की power 2r minus 2. Okay, but in the question आपको equality करना है केस में ना, if the coefficient that means basically the binomial coefficient in this particular case. Now since there are no other coefficient involving except the binomial coefficient, we basically talk about this coefficient. Now question में जो पूछा है that basically the equality of this particular coefficient. That means if it said the question the 34c r minus 1 is equal to 34c 2r minus of 2. Now in this particular scenario we have to basically talk about the equality of this particular coefficient. Now इसके कोफिशिएंट को इक्वलिटी करने में एक सबसे बड़ा क्या चाहता है, that is basically must remember in mind. For example, you have to compare between NCR and some other quantity. Now let me in place of R we write it as A. So NCA is equal to NCB. Now how do we get to this particular relation? एक तो ये रिलेशन हो सकता है कि A is equal to B हो जाए, या फिर एक और एक कंडीशन बन सकता है बेसिकली A plus B is equal to N. ठीक है, ये क्यों होता है? बिकॉज वी स्टडीड अबाउट इंपॉर्टेंट कॉन्सेप्ट NCR is equal to NC N minus R. Okay, NC N minus R. So we can from here we can write this B as N minus A. Okay, that means this B is equal to N minus A. Then in this case that is B plus A is equal to N. So there can be two equation from this particular numbers, from this particular binomial coefficient equality. All right. So if we compare the coefficient that is 34c r minus 6 is equal to 34c 2r minus 2, we can write two equation for this as r minus 6 is equal to 2 times of r minus 1. Also we can write another equation that is r minus 6 plus 2r minus of 2 is equal to 34. So we get two equation from here. Now we have to check for which of the particular term will basically match with it. अब क्वेश्चन में अब पता कैसे चलेगा कि r का वैल्यू कौन सा वहां से करेक्ट आंसर आने वाला है. नाउ वी नो बाय द स्टडी ऑफ बाइनोमियल कोफिशिएंट दैट इज बेसिकली एनसीआर. तो इसमें जो कंडीशन इंपोज होता है दैट बेसिकली द आर इज बेसिकली a whole number that is greater than or equal to 0. Okay, so r is a whole number which will be greater than or equal to 0, and n is a natural number, and n must belong to natural number. Okay, now n must belong to natural number, and such case, and there should not be any such case, that is n should not be less than or equal to r. That means always n should be greater than or equal to r. n should be greater than or equal to r. ये तीनों चीज रिलेशन सेटिस्फाई होना चाहिए in order to get a valid binomial, in order to have a valid combinatorial coefficient, in order to have a valid combinatorial coefficient of NCR. Alright, so अगर मैं इस केस से कैलकुलेट करता हूँ what is the value of r, so we see that is r minus 6 is equal to 2r minus of 2. So if we take this r on this particular side and 2 on this particular side, we get r as some negative value, which is not possible. Since we talked about r should be a whole number, so this particular result will never give me a good value of r or the required value of r. So this particular relation will only give me the required value of r, that is 3r minus of 8 is equal to 34. From here I will get 3r is equal to 42, which means give me the result as r का जो value आने वाला है. From here I will get the value of r as 14, and from here I will get the value of r as 14. So from this particular question we have to basically find the value of r, that the value of r on this question will be is equal to 14. Okay, so I hope this particular question is clear. ठीक है, काफी simple type का question था. ठीक है, and I hope you will remember this type of question. All right, so with this let me start upon the other important note. Okay, so basically some other important note which I wanted to take, okay, for in the end of this particular topic. Okay, now you must remember before ending this particular topics of binomial theorem, now you must remember some key concepts. That is basically whenever we are given with any binomial expansion such that, now most of the question you will basically see in binomial coefficient or expansion as 1 plus x की power something and उसकी power something. Okay, उसका whole की power something. So you have to remember this particular binomial expansion as 1 plus x की power n. It can be directly written as nc0. So we do not write it as nc0. We instead of this we write these terms as okay, this is as 1 plus n into x plus nc2 into x square plus nc3 into x cube and so on up to ncn into x की power n. Alright, similarly if you have a expansion as a 1 minus x की power n, so we write this expansion as 1 minus nx plus 2nc2 x square minus nc3 x cube plus nc4 x की power 4 and so on up to minus 1 की power n ncn x की power n. Okay, now minus 1 की power n, because this minus 1 की power n will basically determine the sign कि कौन सा वाला साइन आने वाला है, that is positive or negative. Okay, so another important note that I basically already talked about. Now whenever I was talking about कि r plus 1 term from n or basically same as of any expansion x plus y की power n is same as the r plus 1 term from the beginning of y plus x की power n. Okay, so we also do another important step, that is basically, so in a binomial expansion of x plus y की power n, so in a binomial expansion of x plus y की power n, if I talk about pth term from end, this will be equal to n minus p plus 2th term. This will be equal to n minus p plus 2th term. Okay, p plus 2th term from beginning. Okay, from beginning of the same binomial expansion. But since this particular process is tedious in remembering, that means you have to basically, इससे अच्छा है कि आप उस दोनों बाइनोमियल का जो वेरिएबल है, जो वेरिएट है, उसको एक्सचेंज कर दो and then basically take out the particular term from the beginning and then say that this is the same term which is the term from the end of that original binomial expansion. I hope that particular relation will be clear. Okay, so इसी के साथ another कुछ ज़्यादा important चीज़ जो आपको याद रखना है, that is basically, ठीक है, आई होप ये वाला चीज़ आप लिख चुके हो, तो लेट मी इरेज दिस पर्टिकुलर क्वांटिटी. ना अनदर एक इंपॉर्टेंट स्टेप जो आपको याद रखना है, दैट इज अ रेशियो विच इज वेरी इंपॉर्टेंट. ओके, ना काफी बार क्वेश्चन में देखोगे इस पर्टिकुलर रेशियो पे काफी ज्यादा क्वेश्चन आते हैं. ठीक है, दैट इज बेसिकली फॉर एग्जांपल यू हैव द r term and divided by the that r plus 1 term divided by the r term. Okay, for any binomial expansion, for example the expansion is expansion of x plus y की पावर n, इसका बाइनोमियल एक्सपेंशन में अगर आपको पूछा जाए व्हाट इज द रेशियो ऑफ द r plus 1 टर्म टू द r टर्म, then you basically write this particular expansion as n minus r by 1 divided by r whole into y by x. ओके, सो ये काफी ज्यादा इंपॉर्टेंट रिजल्ट है दैट यू मस्ट रिमेंबर. ये काफी इंपॉर्टेंट रिजल्ट है दैट यू मस्ट रिमेंबर. ओके, ये काफी इंपॉर्टेंट रिजल्ट है दैट यू मस्ट रिमेंबर. Okay, now how does it come? So now we have already studied about an important topic, important concept, that is NC r plus 1. Okay, sorry, NCR divided by, okay, divided by NCR minus 1. So अब इसको फैक्टोरियल नोटेशन से भी एक्सपेंड कर सकते हो, बट वी नो दिस पर्टिकुलर फॉर्मूला एज n minus r plus 1 होल डिवाइडेड बाई r. तो अगर आप इस पर्टिकुलर टर्म को, जनरल टर्म को लिखोगे और इस पर्टिकुलर जनरल टर्म को लिखने के बाद आप दोनों चीज को कैंसिल आउट करते हो ऊपर नीचे से, देन यू बेसिकली लेफ्ट आउट विद द टर्म दैट इज NCR by NCR minus 1. So that result will definitely give you the ratio as n minus r plus 1 whole divided by r, and this y by x comes from the variable relation. Okay, this y by x comes from the variable relation. तो ये वाला जो टर्म, ये वाला जो रेशियो है, ये काफी ज्यादा केसेस में यूजफुल होता है और आपको अच्छे से याद रखना पड़ेगा. ठीक है, अच्छे से आपको याद रखना पड़ेगा. सिमिलरली और कुछ ज्यादा टर्म्स आते हैं दैट इज बेसिकली, फॉर एग्जांपल, यू हैव अ बाइनोमियल एक्सपेंशन एज x plus y की पावर n, where n is basically a natural number. Okay, a natural number. और अगर इस पर्टिकुलर एक्सपेंशन में अगर पूछा जाए व्हाट इज द कोफिशिएंट ऑफ x की पावर n minus 1, अगर आपको डायरेक्टली इससे पूछा जाए कि व्हाट इज द कोफिशिएंट ऑफ x की पावर n minus 1 इन द एक्सप्रेशन, ओके, नॉट इन दिस, सॉरी, नॉट इन द एक्सप्रेशन, नॉट इन दिस पर्टिकुलर एक्सप्रेशन. ओके, सो काफी बार क्वेश्चन में ये होता है कि यू हैव टू बेसिकली कैलकुलेट द कोफिशिएंट ऑफ x की पावर n minus 1 इन द एक्सपेंशन ऑफ, और इन द एक्सपेंशन ऑफ x minus 1 multiplied with x minus 2 and so on multiplied with x minus n. तो इस पर्टिकुलर रिलेशन के एक्सपेंशन में आपको काफी बार क्वेश्चन में पूछा जाता है कि व्हाट इज द कोफिशिएंट ऑफ x की पावर n minus 1. सो यू कैन डायरेक्टली राइट दिस पर्टिकुलर कोफिशिएंट ऑफ x की पावर n minus 1 as minus of n into n minus 1 whole divided n plus 1 whole divided by 2, n plus 1 whole divided by 2. So this is how basically get to the coefficient of x की power n minus 1 in the expansion of x minus 1 into x minus 2 continued product with x minus n is equal to minus of, is basically equal to minus of n into n plus 1 whole divided by 2. Okay, so you must remember this particular result. Similar result also holds true that अगर आपके पास कोई रिलेशन ऐसा है कि कोई एक्सपेंशन है, x plus 1 into x plus 2 and whole इसके साथ continued product into x plus n और continued product करते जा रहा होगा. So in that particular scenario also, if you have to calculate for the coefficient of x की power n minus 1, x की power n minus 1, okay, this is x की power n minus 1. Okay, so if you have to calculate the coefficient of x की power n minus 1, then you basically get it as, then the coefficient you get as n into n plus 1 whole divided by 2, n into n plus 1 whole divided by 2. I hope these particular relations are clear. All right, so this is all about the today's topic, or basically the basics of binomial theorem. Okay, so in the upcoming lectures we'll basically solve about the most important types of question that basically comes up in JEE mains lectures. Okay, the JEE mains concepts. ठीक है, क्योंकि JEE mains का क्वेश्चन उठा के देखोगे तो काफी ज्यादा 80 to 90% क्वेश्चन होता है बेसिकली इन्वॉल्व्स द कॉन्सेप्ट ऑफ जनरल टर्म. तो नेक्स्ट कमिंग लेक्चर्स में हम लोग जनरल टर्म के बारे में कुछ और डिस्कस करने वाले हैं और साथ ही साथ हम लोग कोफिशिएंट वाले क्वेश्चन सॉल्व करने वाले हैं. और उसी के साथ साथ आई विल स्टार्ट अप द फाउंडेशन ऑफ द टॉपिक ऑफ डिविजिबिलिटी प्रॉब्लम्स. ओके, डिविजिबिलिटी क्वेश्चंस एज वेल एज द क्वेश्चंस ऑफ रिमाइंडर्स. ऑलराइट, सो बने रहिए नेक्स्ट लेक्चर्स के साथ साथ. और अगर अभी तक अपने नोट्स एक्सेस नहीं किया तो इसी वीडियो के डिस्क्रिप्शन बॉक्स में आपको ड्राइव लिंक मिल जाएगा जिसमें मैं बाइनोमियल थ्योरम का नोट्स अपलोड कर दूंगा. ठीक है, तो उस पर्टिकुलर नोट से आप बेसिकली चैप्टर को पूरा एक्सप्लोर करो, अच्छे से पढ़ो, नोट्स बनाओ. ठीक है, एंड साथ ही साथ क्वेश्चन प्रैक्टिस करो. सो क्वेश्चंस मैं अभी आज नहीं डाल रहा हूँ. ठीक है, एक दो लेक्चर्स होने के बाद आई विल बी स्टार्टिंग पुटिंग अप द क्वेश्चंस ऑन दिस पर्टिकुलर डिस्क्रिप्शन बॉक्स ओनली. ठीक है, ड्राइव लिंक से क्वेश्चन डाउनलोड कर लेना और क्वेश्चन प्रैक्टिस करने से रहना. अगर आपने प्रीवियस लेक्चर्स अभी तक देखे नहीं होंगे, आई हैव ऑलरेडी कवर्ड द टॉपिक्स ऑफ मैट्रिक्स एंड डिटरमिनेंट एज वेल एज वेक्टर्स इन 3D. ठीक है, तो वेक्टर्स इन 3D में अगर प्रैक्टिस करना है तो आई हैव ऑलरेडी अपलोडेड द क्वेश्चन बैंक ऑन वेक्टर्स इन 3D ज्योमेट्री, तो उसको जाके देख लेना वीडियोस को. ठीक है, आई हैव आल्सो अटैच उसका प्लेलिस्ट का डिस्क्रिप्शन में इस डिस्क्रिप्शन बॉक्स में भी अटैच कर दूंगा. ठीक है, तो आई होप ये काफी था आज का डिस्कशन के लिए. तो विद दिस आई टेक अ लीव फ्रॉम टुडेस वीडियो. थैंक यू.